Well, hello there. I have only 3 bright students attending my lecture today. My daughter put these dolls in my living room. Anyway, let's go ahead with our technical lecture. My lecture actually is concentrated around the notorious 555 timer, which will generate a frequency that varies with temperature, and that simply will be equal to the speed of sound. And the idea is to have each hertz to correspond to 1 centimeter. Okay, so generally the speed of sound at 15 degrees centigrade is 340.4 meters per second. And when you make each hertz to correspond to a 1 centimeter in distance, and since we are measuring the distance, so that means the sound has to go back and forth, we need to divide that frequency by 2. So we have about 17.05 kilohertz, or to be accurate actually, at 15 degrees centigrade, it should be 17.07 kilohertz. So that means if the transmitter transmits a burst of a sound wave for a whole second, and that echo will come back after 1 second, that means it traveled 17 and 700 centimeters, okay, which is for the sound to travel for a whole second. Okay, the idea is how this is done. Nobody is going to use an old discrete devices to do such a thing, but you can get an idea of how to generate or how to design or build a generator, a frequency generator that makes the frequency varies with temperature. And by the way, speed of sound increases by about 60 centimeters per degree centigrade. So that means for every increase in temperature by 1 degree, the speed of sound will increase by 60 centimeters. And how that's done? This is done based on the delta VBE, or the decrease of VBE for each of these diodes. You see, the VBE of a diode decreases by about 2.3 millivolts per degree centigrade. So the 4 of these will give you something like about a decrease in their voltages of about 10 millivolts per degree centigrade. Okay? And this is how actually we are going to increase the frequency of that generator. Why is that? because as temperature increases, the voltage across these diodes will decrease, and that means more voltage is left for the resistors to charge, which means they are going to charge faster. Okay, so that's the idea. I'm not going to discuss how the 555 timer works, but generally, as you all know, you have a charging cycle and a discharging cycle. Okay, so the charging, it takes place across these diodes and these resistors in here and this one in here too, R15. So the charging current will go through all of these, okay, but the discharging current will go only through R15. Okay, so this is the charging and this is the discharging. And the real equation for the 5.5 timer does not truly apply in this case. The one which you all know, it is the 1.49 divided by RA, or these resistors from here to here, plus R 2 times RB, which is the one in here. This doesn't apply anymore. Why? Because the charging cycle starts from one third of VCC up to 2/3 of the VCC. Okay, and in this case, and the reference voltage inside the chip will divide the 12 volts in here, the supply voltage of the V plus, to 4, which is 1/3, and 8, which is the 2/3. Okay, and in this case, the reference is set to the 2/3, which is the 8 volts, while actually the charging is not from the 12 volts. It will be the 12 volts minus the drop across these diodes, and that drop, of course, that you have in here, the drop, is around, let's say, 0.7 or 0.8. So we are talking about relatively about 3 volts. So whatever the V plus is, you're going to deduct 3 volts here, and that, of course, will make it slower when it charges. That will sure make it slower. The discharge is no problem, because that will be handled internally, but the charging will be slower. That's why you have about 17.05 kilohertz in here. While if you plug these numbers and take these diodes out, you'll get something like about 34 kilohertz. Okay, like about 34 kilohertz. Of course, they can be adjusted to this potentiometer and this 10-turn potentiometer in here. Okay, so this is the idea. Actually calculating these things, I came up with something like about that the deviation of frequency was about 60 hertz per second. It should be 30 hertz only, not 60. I don't know if I made a mistake in my calculations time ago. I have no idea, but I believe that circuit was working and it was accurate. And the idea how to calculate the time inside the chip itself, you have to go to the charging and discharging of caps, okay, with a voltage that starts from 1/3 and goes up to something less than that, because you have in here, like I said, you have about 3.2 volts or 3 volts deducted out of the VCC. So you have to use a special formula, okay, to get something near this. Anyway, this thing works, and it works just fine. Okay, let's see something else, since we are in the neighborhood. Probably somebody might be interested in the transmitter and the receiver. Okay, this is the receiver. It's just a one chip receiver for the echo. And it also uses the notorious, that's the LF347N, that a fit quad op amp. Okay, so it uses just a single chip, as you see here. This is useful for somebody. And the transmitter is also down here. You freeze the video whenever you want if you need additional information. And the transmitter is here. And as you see, this works in a 4 kilohertz for the transmitter. And you set burst of sound and you wait for the echo. And to verify the reading usually should be done twice at least to make sure that the signal was right. More things in here, probably the power supply might be of interest to anybody. That's a 12 volts power supply. Yeah. These are all chips. Nobody deals with that anymore. You go get a computer chip to solve all these problems. A PIC controller maybe, or an Atmel or whatever. There are plenty in the market. And save yourself a headache. And something else to add, that this chip must be installed in the transmitter, because after all you can't put the unit in a cool place where this chip gonna measure the room temperature, while the transmitter is located in a hot place. Okay, so in this case you have no use for the chip. This chip must be very close to the transmitter and it must feel the same temperature. Therefore it will vary the frequency with temperature. I hope that was useful. If anybody interested in more of this stuff, please write something in the comment. I hope that was useful, and thank you for watching.